Mario once again with MIA Microflight, and this is a video continuation of the rubber powered helicopter design series, coaxial type. So what you're viewing here is another coaxial design. This one does not use belt drives, gears, but it's just simply a counter torque control via two frames. Basically one frame that is attached to the lower rotor, which is here, it spins inside the inside the main frame, and so this establishes the anti-torque control for a coaxial helicopter. It's a very simplistic way of doing this without gears and belt and pulleys, like I showed in some other videos. If you look at my first video where I show some sketches, you'll see a couple or a few setups done mechanically to effect the counter rotating operation of the blades. On my second video, I showed a little more details, with the actual mechanics, and in this video I decided to do it this way, as you see it here. And once again, for reasons to keep it very simple and without the mechanics there. This is a very effective way to do this, counter rotating, and it works pretty good. So this is a model. I just put this together a couple nights ago, as you can see here. Now the frame on this one is a little bit different. My other helicopter designs, such as that one that's there, and there's another one that's over there. There's another one that's way over there. Pardon my feet up on my table here, but this is a way for me to do these videos as I relax a little bit here. So I'm discussing these designs. This frame is directly center in line with the center of the mast, which also houses the motor, and so it distributes the weight rather evenly. The trick with these helicopters is also to have the proper balance, so that the helicopter is doesn't have a tendency to fly backwards or forward, unless you really want it to do that. But this one's designed just to fly straight out of the ground. You wind up the rotors, and you just hold on to them and you let go. As you can see here, I'm just gonna kind of try to do this with one hand, so I'm filming with the other hand here. But basically the object is to establish as many turns as you can, as the motor will allow. Once again, these are not torquey motors. These are more they have enough torque, so when the rubber is wound, you have the power to deliver to the rotor, so that it lifts, creates nice height, but it's also able to come down on its own rotation. And basically, I just demonstrated here the operation of the counter rotating blades by this particular mechanism here. So once again, this is just another design. It doesn't take me very long to design these parts in CAD, so that I can 3D print them. As you see them here, these are all 3D printed parts. I have done some other ones in balsa, like those were done really quick in balsa wood. That one needs a rubber band. I broke the rubber band. I'm waiting for some new rubber to come in from a company that's called PEC Polymers. I placed an order, but they have a week delivery time. I think it's what the notice was. I don't know why they take a week, to deliver stuff. I normally get things, it's not a big thing, rubber from a model company. I have ordered before, but it doesn't take that long. I don't know Maybe it'll come this week. I ordered it last week, so I'm waiting for that tan rubber. This is more the darker rubber from SIG manufacturing that I've had for 30 years. The problem with this rubber is that it doesn't last too long. It's I mean it's rubber that's been sitting for 30 years in my storage. But it is allowing me to do some test flights and get an idea, what kind of power I can expect, from the number of strands. In this particular one, I have 2 strands, as you see it there, and but I am waiting for the tan rubber, which should be a lot better. I mean, this one is 1/8. The one that they had, unfortunately, they didn't have 1/8. They had 3/32, so that's what I got. I guess I should look and see what other companies are selling, rubber for rubber powered airplanes or models, and see if I can maybe just place another order just in case. My famous pilot that I keep using, that pilot on pretty much a lot of my models. I explained before that I have used this pilot in the mosquito inspired radio control helicopter that I did, I don't know, maybe 10, 15 years ago. If you look through those videos under MIA ultralight RC helicopter, you'll find those videos. And it's got the same pilot, but I did that pilot more in a three-dimensional form. This is just a profile that's done in 3D printed form. It's printed with 10% infill without the top and bottom layers. So you have just this mesh in the profile, and then I cut out the artwork, and I print that on just regular paper on a laser printer, and then I coat that with a clear coat so that if I'm handling this, the colors don't rub off, and it provides for a nice matted finish. As you can see here, this is just a satin finish on the spray or clear coat, what you're seeing here, and it looks the part. It looks very nice. Keeps it very simple, very basic, and very elegant. And it just puts that touch of realism on these helicopters that I've been showing. So, the stuff that I've been showing, with respect to this particular coaxial design, is how I've been working, since I embarked on this many years ago. Back in the early '80s when I started doing experimentation. Basically, that's how I've been approaching pretty much all the stuff that I do. I just don't make one or two or three. I make when I get into this stuff, I go nuts. I make a lot of contraptions, a lot of mechanical options, because I like to test everything, not just one. There's so many ways to skin the cat, as the saying goes, and so I approach these things with that perspective. More so when I was selling my rubber powered helicopters that turned into radio control kits. Some of the first radio control kits that I used to sell micro, then I went to sub micro, and pound size, such as the MIA Robin 280, the MIA Feather, the MIA Bumblebee, the MIA Housefly. All those radio control helicopters are a direct work of all this work that I did with rubber band powered helicopters. So this is nothing new to me. This is just another. I'm coming full circle here in modern times, just taking all my old stuff that I did back in the day and modernizing it with 3D printed components that you see here. All these components are designed for just to modernize a lot of this stuff. Of course, you can't go too crazy, with 3D printed parts, because these do add weight, as compared to a balsa model like that one right there. That one's 8 grams. That one is 8 grams, and let's put this on the scale and let's just see what this weighs, just for the sake of comparison here. Let me turn on my scale here, and once again, this is the other contraption that I showed before, and then I show one with two crown gears and two just regular pinion gears driving that for coaxial operation. So let's bring this scale. Make sure this is in grams, and it is. So let's see how much this helicopter weighs here. That is 24 grams. That is basically the same weight as my my other one here, which is the this one is the just the single rotor with a, this one uses a fin in the back, and I was playing this with a kid, a little kid, you know, that came to visit home here, a friend of my daughter. She brought her kids, and then I was playing with them yesterday, and we kind of sort of broke that fin there, but I'm gonna fix it. So that one's 18 grams. 18 grams with the with the motor, which is basically it's at the motor there. It's about 20. Let's do this again. That's about 20 grams for that one right there. Obviously, because I'm going with two rotors here, which are they're about the same length as far as the rotors on this coaxial one that I show with this contraption here with this counter rotating mechanism. But because of the extra rotor here, and because I am using a little bit of more plastic here, more 3D printed parts, this shaft is longer, and it's got also a metal hook here. This is all brass. It runs on also brass bearings, brass tubular bearings, I should say. It does add a little more weight here, but you know, this has also more lift because of the dual rotor setup here. You know, you're getting twice as much lift here with two rotors here. A little bit heavier, you know, twice as much lift. You know, it kind of works out the same way as if you know, I were to just keep it as one rotor. They're very lightweight there for the same size. But I did this just for the sake of it, you know, just showcasing some of these contraptions, the way they're done, you know, for coaxial helicopters. This is the boom. I haven't glued this yet because I was experimenting with the length of the boom just to act as a counterweight for the front pilot here. This has to be balanced, because if this is not in balance, you know, it's not going to fly correctly. This also needs some stabilizing fins. Are you ready to try this? It's got good torque, good height, good flight power. But as far as the stability, is this, unlike these other ones there, those are almost very stable by nature of the type of rotor and tip weights that I'm employing there. Notice that I'm not using a flybar there. On those, you could use a flybar. I've shown helicopters also done with flybars. You know, here's a couple of flybars that I did before. You know, and I've been removing those flybars because they do add quite a bit of weight. I also did some, you know, with the tail rotors, you know, 3D printed, and so I bypassed this, and I started to go back to the old methods here of using just balsa wood on the rotors, and I just kept the pulley as the 3D printed part, but the rest is balsa on this particular one that I've been flying. This guy right here. inspired by the Mosquito rubber-powered helicopter. Because if you look at the Mosquito, the full scale, it's just a pod, and boom, and the pilot sits in the front, open frame design with the landing gear spread out, to take most of the load and to create stability while the model, is steady on the ground or, for landing. And so that's where this inspiration comes from. Although there are helicopters that go back to, coaxial and just regular ones, rubber-powered helicopters that go back to the 50s. For anybody that is old enough to remember and have seen some of the old magazines from the 50s. I mean, this goes back to those times. But if we want to go even further, we have Da Vinci, which created some helicopter contraptions. So helicopters have not been nothing new. It's been an idea that's been floating, by for hundreds of years, I think. And but with modern times, you have to modernize this, and what I'm doing here is probably something that I'm probably the only one that has gone this far, to do this and explain this, because I have not seen, to this day, I have not seen anybody explain, helicopters the way I'm explaining, and showing, the variations and showing all the stuff that I'm doing, not just rubber powered, but also coaxial, radio control, and just if you go back and look at the helicopters that I used to produce, back in the early 2000s, the like I was mentioning, the Robin 280, the Housefly, the Bumblebee, those were my creations, for radio control. I'm talking about helicopters that were 4 ounces, 20-inch rotor helicopters with 4-ounce total weight. We're talking about some very, very lightweight radio control helicopters. One of the first of that type in the market back in 2000 when I was producing them. So, I have not seen anybody show this type of work before, and so, this is just another iteration of that work. That, like I said, I'm coming full circle again, because I've done this, back in the 80s. I did this of course, with traditional balsa pieces. Back in those days, we didn't have 3D printers. We didn't have access to the internet, so getting information was not that easy. I have a whole folder that's just right there. I had to dig out that folder. That's all on rubber-powered helicopters, and some of that information there is well, most of it is my stuff, but there's also a lot of stuff that I've acquired. As I was doing this stuff, I started stumbling on people that used to send me information. Said, hey, did you know that this guy did this, back in the day? I didn't know that. So we used to exchange information that way, via snail mail, which is just just writing letters back the old-fashioned way, when I have, like I said, internet. And so we wrote letters, and we corresponded that way, through regular mail. And so I have had customers, they bought my rubber-powered helicopter kits back in the '90s, early '90s, when I would start producing them, and they would send me copies of magazines that they stumble on and say, hey, Mario, check this out. This was done, by so on and so forth. It's kind of similar, nothing like your stuff, because I was taking a different approach. I mean, I started with no information whatsoever. I mean, I had no reference to any powered helicopters that were out there. I just started by nature wanting to learn how helicopters operated, and I said to myself, what better way than to do a rubber powered design for something from simple fins to full mechanics. And so when I embarked on that, I had no information whatsoever. But later on, I stumbled on stuff that I either came across magazines, or the people used to point to me and say, hey, there's a helicopter. This was done by another guy. This was done by in this year. And then this is kind of similar, but nothing like what you're producing, because I was producing more three-dimensional helicopter designs, very lightweight, but more more appealing. Not just a rubber part. I mean, a lot of stuff that people used to send me back in the day were contraptions, just two rotors, one on top of the other one. They would just spin and kind of fly wild. They had no shape. They had no aesthetical appeal to it. Um, and so that to me is like, I mean, that's, I guess you can call it a helicopter. It's just a flying toy, but nothing in a helicopter. The way a helicopter should be designed. This is based on, like I said, on inspired by the Mosquito. And so the Mosquito has inspired. When I came across the Mosquito full-scale helicopter, that inspired me to do the radio control one. And so this is basically the same thing here, which just so happens to be, from a simplistic and logical standpoint, the way people have approached rubber-powered helicopters. Other people that have done that, kind of similar stuff in a more simplistic way. Because you can only, if you want to be super light on this, you just need one stick vertical and then one stick horizontal to hold the tail, either a mechanical tail rotor or just a fin, like I've been showing in all my stuff here. And so there's only one way to do this logically, and so anybody that has pondered on this, with some level of uh, self intuition and thought, is going to come up with the same thing, because you just can't go too crazy with this, because then it starts adding weight, and the more weight you have it, the less flight time you have, the less height you're going to have with this. I mean, you can put a really torquey motor, as I've said before. You can put 3, 4, 6 strands of the same type of rubber here, and it's going to create a lot of torque. But the problem is, when these things take off, they take off high, and then the rotors stop, because you don't have enough turns there, and so it doesn't have enough power to come down on its own. So what you want, the trick here, is to have a helicopter that's balanced, in all respects. Not just in power, but it is also not just in balance and in counter torque and counter rotation, but it's also balanced with the proper strands of motor, the proper winds on it, and as we're trying to maximize the power to weight ratios here, but we also want to maximize the number of turns on these with its minimal strands, that we want to have enough torque in it, but a lot of turns, so that this helicopter is able to go up and come down on its own, with some level of realism. So anyway, this is just another take on designing coaxial helicopters from MIA Microflight, and this is Mario once again. Thanks for watching. Stay tuned for more.